Hello students, in chapter 10 straight lines, students welcome. Today continue students our exercise example 4 related slopes, and students already I explained slopes have 4 major topics: definition of slopes, point wise y2 minus y1 by x2 minus x1. If a line given ax plus by plus c, then slope is minus a by b. If you angle given positive direction of x-axis, then tan theta, and fourth case dy by dx. And also we studied last part parallel between two lines, that condition m1 equal to m2, and two lines are perpendicular, then yes, m1 and m2 is equal to minus 1. That principle utilizations today we going ahead, example 4.5 and exercise 10.1. So in example 4, P, Q and R already given, lies on a line, prove that types of sum proving. Students, lies on the same line means they are collinear. So you have to, that is the one of the line, P something next point, next point. Anyone there you write down, I written P, Q, R. P I have HK, Q I have X1, Y1, and R I have x2, y2, and all are between all lies in same line means collinear. So here P comma Q comma R are collinear points. That's why slope of a same line, PQ line, QR line and PR line. So we will write down here slope of PQ line is equal to slope of QR line. Either you can write down slope of PR line. They all are same. So what is the slope formula according to point? y2 minus y1 by x2 minus x1. So I put it here, y1 minus k and x1 minus h. Now QR, y2 minus y1 upon x2 minus x1. Students, check y1 minus k, already you proof k minus y1. So you just take minus common. Here I take just minus 1 common. So k minus y1. Here also minus common, h minus x1. And the same y2 minus y1 by x2 minus x1. Minus minus cancel. Other you cross multiply. Your numerical done. So students, my data is over here. K minus y1 into x2 minus x1, same as h minus x1 into y2 minus y1, and that's become your final and easily students example 4 here proving done. Now continue students, after fourth example we going ahead fifth. It's very interesting questions. Already figure given. In a given figure, time and distance, here time given on x-axis, distance given on y-axis. As a linear motion is given already, and the position of the two, time and distance are recorded as, if a time t is 0, then distance is 2 cover units, and when a time 3, I mean second or either minute, and distance d is equal to 8. So here 2 points given, 0 to 3, 8. Third also given TD, and asking there, using the concept of the slopes, find the law of motion. Indirectly asking that how distance depend upon time. So this question are same question. Points are, I just indicate here P, Q and R. All are collinear. Slope same. PQ slope and QR slope, either PR slopes are equal. So just here same explanation, P comma Q comma R are collinear points. It means slopes are same. So I just written slope of line PQ is equal to slope of line QR. That's all. PQ slopes and QR slopes. The slope formula apply, y2 minus y1 by x2 minus x1, that you know. So PQ slope I just added 8 minus 2 by 3 minus 0. 8 minus 2, 3 minus 0. Same QR slope, d minus 8 by t minus 3. y2 minus y1. It means this you are taking x1, y1. That take x2, y2. d minus 8 and t minus 3. Students, now simple. Here 6 and 3. d minus 8. You can cancel that too. And cross multiply. They get answer. 2t minus 6, d minus 8. So 2t minus 6 plus 8 is equal to d. So d is equal to how much? 2t plus 2 and 2 common, t plus 1. That's the equations you create by the distance versus time, either time versus distance. And here students, your example 5 is also done. Now I going ahead our exercise 10.1 related first question. Now continue students, exercise 10.1. Find the area of given all 4 coordinates of the quadrilateral and also draw its easily Cartesian plane. So first I derive the drawing, after that you get to area. So students, your point is a plot on the respectively coordinate plane. Just kinda here y-axis taking, that is the x-axis taking. And I simple draw your x coordinate minus 4 to maximum 5. Minus 1, minus 2. You use pencil scaler? Yes. 1, 2, 3, 4, 5. Maximum 5. Now y-axis maximum 7. Minimum minus 5. So minus 1, minus 2, minus 3, minus 4, minus 5. And here 1, 2, 3, 4, 5, 6, 7. 6, 5, 4, 3, 2, 1. And now plot your points. Minus 4 comma 5 means approximately here, point say. Second point 0 comma 7 is here. Third 5 comma minus 5, just like here. And last of the D minus 4 comma minus 2, just here. Yes, D points. Now all points join them. A to B, B to C. You draw using scalar. D to C and A to D. That was straight moving here, passing through on it. Now this quadrilateral sketch, but I want to area of triangle. We know that. So can I made here? That is the one of the line joining between them. ABC area defined and ADC area defined. And both area students I add at the ending of the sum. You can get easily area. So now I start our property area of triangle. Students, you also make a not compulsory AC, you also making the BD, ABD and BDC triangle. That also true. Anyhow, you can draw two triangles, possible two triangles, and easily make the area between them. And then after you add it. That's your simple solutions. So I joined now ABC area. So in a triangle ABC, A I have minus 4, 5, B is 0, 7 and C 5 comma minus 5. That's x1 y1, x2 y2 and x3 y3. And students, apply area of triangle. So we going here, simple formula, area of triangle ABC, half x1 bracket, x2 bracket, x3 bracket, and internal apply y, 1, then here 2, 3, 2, then 3, 1, and 3, then 1, 2. Now put down your values. x1 I have minus 4, x2 0, x3 5. Now y2 minus y3 means here 7 plus 5. Now y3 minus y1 minus 5 minus 5. And third, y1 minus y2. y1 minus y2 is a 5 minus 7. Just to compare it. So your data half, here minus 4, 7 and 5, 12. 0 and here minus 2. 5 minus 7. Now get the answer. So students, half, here 12 4s are 48, and that become 10, and 48 and 10 58. So half become minus 58. So your answer 58 by 2, either 29. Statement 1, students. Now we going ahead. Next of the cases, area of triangle ADC. Yeah. Now in a triangle ADC, students, you can apply AD to C. A I have minus 4 5, D also minus 4 minus 2, and our C I have 5 comma minus 5, and here you apply x1 y1, next x2 y2, and next x3 y3, that types. Now also you create same property, area of triangle. So students, we going ahead slowly. Area of triangle ADC, rule same, half x1, x2 and x3, that way. And internal value apply, y minus y, same, y minus y, and here apply 1 then 2 3, 2 then 3 1, and 3 then 1 2. Now value put it. So half, what's your x1? Minus 4, x2 again minus 4, and x3 become 5. Now value apply, y2 minus y3, y2 minus y3, it means minus 2 plus 5. Now y3 minus y1, it means minus 5 minus 5, and last y1 minus y2. y1 minus y2, it is 5 plus 2. y1 minus y2, it is 5 plus 2. And now calculate. So half, here minus 4, it become 3, minus 10, and here 7. So half, you can create your simple answer. 4 is 12 plus 40, and 7 5s are 35. So students, your data is 40 and 35. It becomes 75. Yes, 75. 7 and 4, 75 minus 12. It gets 63. So half into 63. So your data 63 by 2 square units. Statement number 2. Students, here area of ABC done and ADC done. But I want to full area. Means both of the additions. So area of quadrilateral ABCD is simple. Area of triangle ABC plus area of triangle ADC. Now what's the ABC? ABC is known, 58 by 2, because I take LCM again 63 by 2, and that become additions. So 58 plus 63 by 2, 8 and 3 11, 1 carry, 6 and 6 12, means 121 by 2 square units. That's your students final answer for this. My first question is happily students here done. Now students, we going slowly. Question number 2. The base of an equilateral triangle with the side 2A lies on the y-axis such that the midpoint, its origin of the sides at the origin. Find the vertices of the triangle. Students, here also we go the drawing wise. That's a triangle, y-axis related, I draw base and x-axis here. Consider here your triangle is our equilateral triangle, but that is your midpoint 0 0, and that is A, B and C. So check what is the side 2A, means that become I write down 2A sides. This also write down 2A sides. This also 2A, but midpoint, that's why here I write down A, and this also A. And this total length is a 2A. Very simple. I just take one of the right angle triangle and this distance I assume K. So sure the coordinate is what? K0 on the x-axis. And I will going now Pythagoras theorem. Triangle AOB. AB square equal to OA square plus OB square. So I just assume that suppose AK, 0 on the x-axis, which is distance from 0, 0 is k units. It means I will go now simple our Pythagoras in a triangle AOB. Angle AOB is what? Pi by 2. So Pythagoras apply. AB square is equal to OA square plus OB square. And apply the AB to I say OA K and OB your A square. Now you can draw simple find out K value. 4A square minus A square. So how much K square? 3A square. So K become plus or minus root 3A. Why plus or minus? Because this side also another triangle we will draw after decision of K. So this value is students A dash minus root 3A, 0. And here plus root 3A, 0. That means vertices are clear. These vertices are 0, minus A, 0, A. Either this triangle true, either this triangle true. Midpoint base on y-axis midpoint. So required vertices are A, we direct write down root 3A, 0, B 0, A, either C 0, minus A. Otherwise this also true, A dash minus root 3A, 0, B same this sides 0, A and C 0, minus A. It means students either this criteria true, either this side true. And here students we easily complete here question number 2 also done. Now I go to third one. Now continue students, third one. Find the distance between P and Q if P given x1, y1, Q given x2, y2. If a parallel to y-axis cases, either parallel to x-axis cases. So I go to first. The first question is PQ is parallel to the y-axis. The students, your drawing is you judge in this way, that is your consider x-axis points, y-axis 90 degree to origin, and I draw the PQ parallel to y-axis. It means this one is y parallel. Definitely this coordinate here x1 and x2 both are same because they bisect only unique one place. X-axis P's are given x1, y1, but Q is given x2, y2, but we write down here x1, y2. In place of x2 we will write down x1 because a line intersect with x-axis at unique point, then they are parallel to y-axis, no? So my distance PQ, apply the distance formula, x1 minus x1 square plus y1 minus y2 square. They become 0 and y1 minus y2 square. Indirectly y1 minus y2 modulus. You derive your modulus because distance never be negative. Already we written in first part. Properties of distance, never negative, either positive, either 0. So y1 minus y2 my distance, either y2 minus y1. Now second case, I go to parallel to x-axis. So second case is PQ is parallel to the x-axis. So students, you can draw just one more line, y-axis and x-axis. here 90 degree, but now go to parallel to x-axis, it means that one. Here I taking y1 and y2 same. Then they intersect a unique point at y-axis, and this line is considered P, here Q. Students, here x1, y1, but Q is written x2, y2, yes, x2, y2. In place of I write down x2, y1. Because y1 and y2 are unique, then they are parallel to x-axis. So students, here also same I going distance PQ under root x1 minus x2 square plus y1 minus y1 square. I just operate your distance formula. So students, here finally done. X1 minus x2 square plus 0. It's a modulus. And that's the distance you create PQ if a line is parallel to x-axis. Now I continue, students, our question number 4. Yes, fourth is a very simple question, and I hope you easily understood that type of numericals. Question number 4. Find a point on the x-axis. Find a point on the x-axis which is equidistance. Condition is which is equal distance, either equidistance from the points 7, 6 and 3, 4. 7, 6, 3, 4 equidistance. So students, very simple. Consider this is your x-axis, and I assume that on x-axis some point just like a P. You know that P x, 0 on the x-axis, and A and B, consider that's your points A and B. A is your 7, 6, 3, 4. First I write down left side 3, 4. Here write down B point 7, 6. And these both are equidistance from it. It means PA distance, PB distance are same. This is a roughly drawing I draw because P is unknown, that I not known where it is P. So I just going, suppose Px, 0 on the x-axis, which are, yes, this condition I again written, which are equidistance from A 3, 4 and B 7, 6. And equal distance means only PA equal to PB, PA square equal to PB square. Now students, you can apply a distance formula. P to A, x minus 3 whole square, 0 minus 4. Same P to B, x minus 7 whole square and 0 minus 6 whole square. That one. 6 minus 0. Now expanded. X square minus 6x plus 9, 16. X square minus 14x plus 49 and 36. This are cancel. So minus 6x, 16 and 9, 25. Here minus 14x, 49 and 36. Just I added 9 and 6, 15, 1 carry. 3 and 1, 4 and 4, 8. Add 5. Yes, now you calculate simple way. Minus 6x plus 14x. 85 minus 25. It is 8x, and here 0. It becomes 60. Now students, 8x is equal to 60. So x become 60 by 8. 15 4s are and 2 4s are. So your data is only 15 by 2. This is your x coming. But I want 2 points. Therefore, required point on the x-axis is P x comma 0. That's the main point. 15 by 2 comma 0. And here students, our question 4 is also happily done. Now students, next one, question number 5. Find the slope of the line which is passes through origin and also passing through midpoint of the given P and B points. So consider this is your P and B. I just suggest in this way drawing 0 minus 4 and 8 0. And I want to slope of the line passing through origin and midpoints. So this is your midpoints. And this line I just consider passing through origin O points. This is a roughly drawing, don't worry. But I anyhow derive the midpoint. Yes, midpoint M become x1 plus x2 by 2, y1 plus y2 by 2. And the value is 0 plus 8 by 2 comma minus 4 plus 0 by 2. That become 4 comma minus 2. And here students, we will write down here M coordinate 4 comma minus 2. Now a slope defined MO line passing through O and passing through M. So now slope of OM line. Formula is y2 minus y1 by x2 minus x1. And apply the value 0 minus minus 2 by 0 minus 4, 2 by minus 4, which is minus half, and that is the slope of the our given line. Students, here 0 minus of minus 2, it means plus 2, and 0 minus 4, your answer there. Now continue students, question number 6. Without using a Pythagoras rule, prove that given three vertices are the vertices of right angle triangle. So this right angle triangle means 1 degree must be 90 degree, and 90 degree utilizations using slopes. Slope of between two lines, I will apply both product minus 1, then we will prove it is a right angle triangle. So simple way, first of all I given in a triangle ABC, A 4 4, B 3 5, and C minus 1 minus 1, and you can operate here x1 y1, second x2 y2, and third x3 y3, and A 4 4, B 3 5, and C minus 1 minus 1. Now I anyhow derive slopes. So slope of first line AB, y2 minus y1 by x2 minus x1. So you can operate here y2 minus y1, 5 minus 4, 3 minus 4. So 2 by, here 5 minus 4, 1, 1 by 1. Students, minus 1, it is minus 1 value. 5 minus 4 1 and 3 minus 4 minus 1. I want to slope of multiplier minus 1. Next I going slope of second BC line. So B to C apply. Minus 1 minus 5, minus 1 minus 3, minus 1 minus 5, minus 1 minus 3. So here students, minus 6 by minus 4, it gets 6 by 4, it means 3 by 2. So this also same going third, slope of line what? Now AC. If you all slopes are same coming, then it is collinear. But I going to triangle, then non-collinear, slopes are different. Now A to C relate, minus 1 minus 4, minus 1 minus 4. So minus 5 by minus 5, it become 1. Now check students, this slopes, that slopes. If you both multiply to each other, definitely minus 1. So now I showing that slope of line AB into slope of line AC is equal to minus 1 into 1, indirectly minus 1. You check here which point is common between them, A. So definitely your drawing is this, here a right angle at the place of A, and that's your BC students, B to C line, and that's the 90 degree. Therefore we will say BAC is a pi by 2. So triangle ABC is what? Our target is achieved. Triangle ABC is, yes, right angle triangle. And therefore our target is achieved. Our given vertices are the vertex of right angle triangle, easily proved. Students, here not a utilizations to any Pythagoras property, because here given without using Pythagoras you prove. Yes students, here up to 6 numerical I stop this part, and further 7 numericals to students I go to in next part. Bye bye.